Hello, welcome back to Plumbing College. Today we are going to be doing every plumbing student's favourite type of pipework, low carbon steel. We are going to be installing low carbon steel pipework to a radiator following a diagram, and it involves doing a semi-pass over bend. So with low carbon steel pipework, you wouldn't install it in someone's home. This is designed more for commercial use. So for example, in factories or places where it's prone to get damage to pipework. So for example, in schools or public places. So you can only really use this pipework on heating systems and gas pipes. You can't use it on cold water because it will rust. To use steel on cold water systems, make sure the steel is galvanized steel, not low carbon steel. From the datum line, we're going to measure across 1150 and 1250. That's where the two pipes are going to go. Remember, for low carbon steel, we use 1/2-inch school ball clips for this. Okay, so we need to work out where we're going to put all this. Okay, so what I'm going to do, how I'm going to do it, is I'm going to find the middle from here to here. That's my starting point. So in this case, it's the middle is 37. So 18.5. Is there. My first clip is going to be here, so we can level it. Right, the next one we're going to measure, that was 18.5. We're going to measure up 18.5. Which is there, there, and there. So the next clip is going to go there, like that, in the middle of the radiator. And what we then do, we then measure from there to there, that clip to that clip distance, which is 410 mil. From 410 mil. So what we then do, measure up from this clip here, 410, which is there, 410 mil. Do two level lines, which is there, like that. Okay, so that is 1, 2, 3, 4, 5, 6, 7 clips for this. All right, so what we then do with these clips, make sure that the line, see the line there, is in the middle, like that. Let's straight me to mark 1 hole, 2 holes. It's in the middle. It's in the middle. radiator on, we've got the clips up. That's what we've done so far. Right, so what we're going to have a T here. The pipe is going to finish here. It's going to go this way into here. And also it's going to just go down here and stop here. Okay, so how do we, so with low carbon steel, we need to cut it right, because we can't, if you cut it wrong, it takes a while to recut and rethread. So we need to get it right on the first go. So what we do, because I've already marked out all the clips, we can measure from the middle of this pipe here to the top, which is going to be, so from the middle of the pipe to the top, right, is 80 centimetres or 800 millimetres. Okay, so we will make a note of that. So 800 millimetres. And when we look at the manufacturer's instructions, the Z dimension for this fitting is 15 millimetres. So if we take off 15 millimetres, that will be 785. So if we cut this pipe 785, it will finish in the middle and at the top here. So pipe 1 equals 785 millimetres. Right, pipe number 2. Right, so pipe number 2 is going to be a T and an elbow like this. Draw a line there. Okay, so that's the middle to middle. And if we now measure middle to middle, that is going to be, so the middle to middle is, so from the middle of this valve to the middle of this pipe is 400 millimetres. And looking at the diagram of Z dimensions, the Z dimension for a T is 15 millimetres and the Z dimension for an elbow is 15 millimetres. So we take off 30. So we then make a note. So that is going to be 400 millimetres take away 30 equals 370 mm. Right, so luckily for us, the low carbon steel pipe, because it's a new length, one side is already threaded. Okay, so that is going to save us 5 minutes. Right, so the first measurement is going to be 785 millimetres, which is there. So 78.5 centimetres or 785 millimetres. We're now going to secure it in the vise. Okay, and we are going to use an adjustable pipe cutter to cut this. So making sure the 3 wheels, so we make sure that this one here, where it cuts, is on the line. So like that. What we then do, turn it. Don't do it too tight, otherwise you'll damage the wheel, cutting wheel. Turn it a little bit more. One of the downsides is it leaves an internal burr using the adjustable pipe cutter. So it cuts it straight, but it just leaves a burr. So we need to file that. Out now. This is before and this is after. So that's the other side of the pipe, this is after. Right, so now using our cutting compounds, we'll put some cutting compounds around the pipe. Okay, so what we then do, make sure it's the 1/2 inch stock and die because it's 1/2 inch pipe. Push it on, make sure the arrow's facing righty-tighty. Push it in. And then give it a bit of a push to get started. And after a few turns, you'll feel it start to push. We can then just carry on. Well, if it does get a bit hard, that's what's happening. It's getting a bit hard. Is inside. It's getting jammed up. It's all getting jammed up. So it's getting really hard to turn. So what we're going to do is we're going to turn this the other way, release all the spoof, and then carry on. When you do this, go to the end of the pipe needs to touch the end of the teeth, not the end of here. It needs to go here. That's correct. Okay, so that means that you've got a thread which is 13 mil deep. I can change yellow. Get some thread sealing tape, starting from the back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. And we then get our T. Right, remember folks, it's bad practice to use tools on fittings. Okay, so never do this, never do this. Get an off-cut of pipe, which I call a Tommy bar. Just screw it on, just hand tie it, and then do it up like this. Nice and tight. Okay. Right. Again, I'm not using any grips on the fittings, okay, bad practice. So the pipe we've just done, we'll put in place. Let's have a look. Right, so what we're going to do now, so this piece of pipe from here to here, which is where the stop end goes, this measures end to end is 120 millimeters. But we know it goes inside 13 mil and 13 mil. So we add on 26. So this piece of pipe needs to be 146 millimeters. So let's thread this, do it up. So we just have to do this one up in situ. That's our next job. My next bit of the equation is we measure from there to there, and we add on 26 because it goes in 13 mil and 13 mil. Right, so in this case, it's measuring 50 mil. From there to there is 50 mil. Plus we're going to add on 50 mil, 76 mil. So this pipe from there to there is going to be 76 mil. So let's do that one now. Right, when we come to thread this, because it's going to be a bit short to thread, what we're going to do, we're going to put this in here just temporarily. And what we're going to do, and we'll thread it. So using the pipe, so let's have a look. So this goes there, this goes there, this goes there, this goes there. Let's see if we can get it. I've just about got away with it. As we can do this one up with a spanner. That's that. We can then lock the clips back in. So right, so we've just done the same for this side. We've put the T in, stop end, and we've done it using the same techniques as we've done for this one, so using the Z dimensions. Now we need to do a semi-passover bend to the specifications of the diagram. Let me show you how. Just what goes around here with a 20mm clearance gap. Right, so remember, these pipes here are 100mm apart. So for this, we're going to have to draw it out. So draw a line. Like that. Right, so that's a low carbon steel pipe. It's got to have a 20mm clearance above it. That's what we do. So this pipe work is, so this is about 21mm outside diameter. 15 mil inside, so 21 mil. So 21 mil plus 20 mil clearance. We find somewhere in the middle, we draw a line like that. Now we've done a line in the, drawn a line downwards, square line. So that's going to represent the right hand side pipe on the diagram. And we're now going to measure this way 100 mil to represent the left hand side pipe. Okay, which is there. Okay, so that cross there, so from there to there, it's 100 mil. It's 100 mil from there to there. So that's one pipe going downwards, and that's the other pipe going downwards. And to keep it symmetrical, we're also going to measure 100 mil this way for the bend. We'll see what I mean in a minute. Right, so using our famous folding ruler, we set this angle to this angle, like that. That's what our first bend is going to be on the hydraulic pipe bender. We'll get some low carbon steel, just put it in the bender to about there. We get our piece of pipe we've just bent, and we line it up on the diagram so the top of it's touching there, and also the gaps are the same. So say like there. Okay, so it's touching there, and there to there, the gap is the same, like that. Right, what we then do is where the edge of the pipe touches, and draw a line like that. So we've come along here, and where this pipe touches, we've done a line here, like this. Okay. Right, and this line touches the middle of the former and the pipe bender, and it faces this way. Like that. I'll give it a few pumps, make sure the line's in the middle, which is about there. And we also have to make sure that it's all nice and straight. Right, what we then do, then set the folding ruler to this angle. To this angle here. So I've bent this to this angle, if you can see it, this angle and this angle, like that. Okay, all right, we then take it out. Right, so that's sort of how it's looking so far. All right, so we then put our work back into the diagram, like that, like that. Okay, so that's the bend. That's how it's looking. So that's on there. And this is there. So there, that's sort of how it's looking on the, that's where I've cut it. Like that. So just to show you. Have a look. There, 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 there. Okay, so that's how it's looking. So just check the gap. 20mm gap, which is there. 20mm, like that. Right, so that's how it's looking so far. Right, so here we've got a T with a drain valve going in. Right, so what we're going to do is I'm going to mark the middle of the valve, which is there. Right, so looking at the, right, so we now know if we measure back 15mm from here, so that's the middle, we need to measure back 15mm, which is there, so there, so we need to cut a little bit off there. 15mm is the Z dimension. Is we're going to make sure that both valves are open, so the wheel head valve is open and the lock shield valve is open. Right, okay, that'll do. Yeah. No, all the joints are done up tight, so we are now ready to pressure test it. We've capped off one end, we're going to pressure test it. Let any air out the radiator. Right, so we've tested this at 3 bar for an hour, and there's no leaks and the pressure's not dropped. We waited half an hour for it to stabilise, and because it never dropped in the stabilisation period, it stayed at 3 bar. We didn't need to top up the pressure. We waited an hour, and there's no leaks, so it's passed the soundness test. Okay. Once it has passed the leak test, the next job, there's 2 more things left to do. We need to remove any excess PTFE tape using a Stanley knife. Do all that now. And the other job is we need to remove any tool marks. So it's where this has been in the vise. If a child or someone grabs this, it's quite sharp from where it's been in the vise. So we need to spend a minute just filing off any tool marks. Now you know how to install low carbon steel. It's your turn to have a go. Good luck.